Hello students, good evening. So today we are going to start one of the very important topics for the JEE advanced level, because in the entire mechanics, right, the if you look at the past JEE advanced paper, you will see that most of the questions, right, will be somehow or the other way related to the rotational motion or the angular motion. Okay, so system of particles, where we'll apply the conservation principles of energy and momentum, or the rotational motion. These are the areas where we'll see that a lot of application scope will be there, and that's why we'll see that in JEE advanced level, right, we tend to get either questions from the core of this area, or kind of a combination of, or merging with the other ideas like kinematics or laws of motion, etc. Okay, so we'll just get started with this topic. So this chapter, right, we can break it into two. I mean, actually, in some JEE advanced or JEE mains level textbooks, if you see, right, they will divide this into two chapters. One, they will call it as system of particles. Other will be the rigid body motion and rotational motion. But here, we are trying to club this as a single chapter, but we'll cover it as a different segments only. Okay. So we'll have to separately study about the system of particles. Okay, so once we understand about system of particles, right, we will be able to know what is a body. Okay, what is a body? It's a collection of system of particles which are closely packed. System of particles means anything which is generally like, you have 3 particles like that, 4 particles like that. That also you can call a system of particles. Okay. What do you mean by body? A body is basically a closed packing of the particles. We'll see. I mean, what is the difference between the two? We'll see. So once we understand about the system of particles, right, then we'll be able to talk about the motion of the body. But even in the JEE advanced level also, right, we don't get questions framed on the elastic bodies. Elastic bodies, we don't usually get questions framed on it. What we have is only the rigid body motion. We'll see what is the rigid body also, we'll see. So rigid body, we'll talk about 3 types of motion for the rigid body. One is the translation motion that we have been discussing for so long. Second will be the rotational motion. That is what we'll study. The rotation motion of the rigid body, right? That is the second part of the chapter. And the third will be a combination of these two. Translation plus rotation. Okay, so we can call it as what? Combined motion. Translation plus rotation is called as what? Combined motion. One special case of this combined motion is the rolling. So what is rolling? It's a special case of the combined motion. Okay, so all these we will be able to see in the chapter, but first let us just try to understand what is this system of particles. See, particle means what? Generally we are talking about the point mass. Point mass is theoretical. So we say that mass m1 is at a location. Can mass be at a location? No, right? Mass will actually spread in a volume, isn't it? But the theoretical idea of point mass, right, that is what we take as a particle. So if we have like 2 particles, 3 particles, 4 particles, that entire set of particles together, that is what we call as the system of particles. Okay, now the first leg of the chapter is to understand how we can study the motion of the system of particles. So what is the thing that we are going to focus here? How do we study the motion of system of particles? Okay, and as I said, right, when we have a object or a body, we can also call it as an extended body. You know what this is? This is nothing but, think about it. Okay, so if you take any object or body, how many points you can mark on the body? Theoretically we can mark how many points? Infinite number of points, right? It will not be like, you have a, like say, even this marker pen, I ask you to mark point masses on this. How many point masses will come? Infinite number of point masses will come. Okay, so the extended body or the object or the body in general, when we say that, right, it is a collection of how many number of particles? Infinite number of particles. So an object or a body will have infinite number of particles. Generally when we say system of particles, right, we keep using this word discrete, means like countable kind of thing, like maybe 2 particles, 10 particles, 50, even 100 is countable, 1000 is countable, lakh is also countable, crore is also countable, like that. Infinite means that is something which we will not be able to count it. So that is what is the number of particles in a extended body or an object. Okay, now we will see what is the rigid body, because we said in our syllabus, right, we are going to mostly focus on the rigid body. For that we can just take these very straightforward examples. Look at this. What is on our left side? Rock is there. What is on the right side? It's a rubber band. Okay, I ask you, what is the fundamental difference between the two? A rock, we cannot compress it, we cannot expand it. Okay, so in simple, right, we can say the rock cannot be distorted, its shape and structure cannot be changed. As a result of it, so let us try to understand this more in terms of the physics importance. Cannot be distorted is okay. Anyway, we'll study about this in the properties of solids. In properties of solids, right, we'll talk about the solids, what happens to a solid when we try to deform them. Okay, but here if you look at it, right, let us look at the point masses on that rock. When I say the rock cannot be distorted, right, the separation between the points that you mark, right, will remain same, because if I can distort means separation will get changed between the particles. If I am not able to distort means what? The separation is going to remain as it is. That is the significance of the rigid body. Whereas if you look at the rubber band, right, you just try to apply some force, the rubber band will simply get elongated. Okay, so the rubber band will get what? Elongated. As a result of it, you mark the particles on the rubber band. When you are able to elongate it means what? The separation between the particles, right? Separation between the particles will be, it can change basically. As a result of this, what happens, if you want to study the motion of an object like this, so this is what you generally call as the elastic objects. Okay, which we are not able to distort, we call them as what? Rigid body. If you want to study the motion of the elastic objects, right, it gets a little bit more complicated, because the separation between the particles of that object, right, they keep changing. So as a result, right, the study of motion of the rigid body will be easy in comparison to the study of motion of the elastic body. So elastic body, it gets a little bit more complicated. We will see how it gets complicated, because if you want to understand how it gets complicated, we should first start seeing the motion of system of particles, isn't it? From there only we will be able to know, because system of particles is what? Countable number. So countable number, okay, we are able to study the motion of particles. When the number of particles becomes very large, like in the case of the extended body, it may be a rigid body, it may be elastic body, we will have to see how the study of motion will be relatively simple in case of the rigid body, and how it gets complicated in the case of the elastic body. That we will see as we go into the discussion. Okay, but this is the general idea of what is system of particles. What do you mean by an extended body? And extended body, we are kind of classifying them into what? One side we have so Sarah, you good? Okay, so we are classifying them into what? One side we have the rigid body, other side we have the elastic object. Okay, so we'll just start with our discussion of study of motion of the system of particles. If you want to study the motion of system of particles, or study the motion of an extended object, okay, because system of particles means what we said, there are many particles, right? Like say for example, m1 is there, m2 is there, m3 is there, m4 is there. They may be moving in different directions. They need not move in the same direction, right? They can be moving in different directions. Now how do we understand the overall motion? See, m1 may be moving in one direction, M2 may be moving in one direction, M3 will be moving in different way, M4 will be moving different way. If you want to study the overall motion of that entire system of particles, right? Overall motion of the entire system of particles can be studied if we are able to observe the motion of what we call as the center of mass. So we'll have to see what is the center of mass concept. Okay, so we have system of particles, or even we have an extended object. Extended object means the number of particles is infinite. First, let us begin with the system of particles. If you have system of particles, the particles can be moving in different directions, right? Already we saw that in case of collision and all that, right? What do you see? The particles moving in different directions can come and collide like that, we have seen. So if you observe, like say group of 5 particles, 10 particles, they may be moving in different directions. They can have different velocities. They may be experiencing different accelerations. In a given time, they can be traveling with the different displacements. All of them can be different. Then how do we study the motion of the entire system of particles as an overall picture? That can be done if we are able to track. So we have to identify what is this center of mass. If we are able to identify the center of mass, right? So center of mass will be indicating the location. Center of mass will be indicating what? It will be indicating location. If we are able to track that center of mass, right, we will be able to get an overall idea of the motion of the system of particles. How tracking center of mass will help us understand the motion of the entire system of particles, we will have to see. But first, let us try to understand how do we locate the center of mass. There are two things here. First thing is what? We should know how to locate the center of mass. Then we will see what is the significance of center of mass. What are we saying here generally? Center of mass, if we are able to locate, means if we track that center of mass location, then we will be able to understand the overall motion of the system of particles. How it happens, we will learn. So we'll have to learn two things here. First, we should know how to identify the center of mass. Second, we will see how tracking center of mass will help in understanding the overall motion of the system of particles. Okay, so we are going to start with the discussion about the center of mass. So center of mass, right, as we said, it is going to represent what? It is going to represent a location. What is this location? The location is going to be a theoretical point. It's not like, we keep using the word center of mass point like that. Center of mass point means it is not like there is something there. It is a theoretical point where the entire mass of the system of particles or object. In case of system of particles, we say system of particles. In case of extended body, we will say object. Okay, so it is a theoretical point where the entire mass of the system of particles or the object is assumed to be concentrated. So we will assume that the entire mass of that system of particles or the object is concentrated at that theoretical point. It is not a real point. This is basically what we are assuming, that okay, the entire mass, let's say we have a system of some 4 particles. Okay, if I say that this is the center of mass location for this system, then for our analysis, right, we'll assume that the entire mass of the system of particles, means what? M1 plus M2 plus M3 plus M4, that is the total mass. We'll assume that the total mass is located at the center of mass point. That is the way we are going to talk about the center of mass. But this is what is it? It's like a book statement. So how do we really find the position? Because if we say that is the location, we should be able to find the position, right? It means what? We should be able to find the coordinates of the position. Means in space, right? We should be able to tell what is the x coordinate of center of mass, what is the y coordinate of center of mass, what is the z coordinate of center of mass, like that. So here the way we will do it is, first we will talk about how do we find the center of mass for system of particles. Okay, so first we will see how do we find center of mass location for the system of particles. Then we will see how do we find the center of mass of the extended body. So first we will see how do we look at the center of mass of the system of particles. Then we will see how to find the center of mass of the extended body. Okay, so we will just get started with the task of, what is our task now? To locate the center of mass of the system of particles, or that's what we are calling as a discrete particles. Means what? Countable. It may be 2, it may be 3, it may be 5, 10, maybe 1 lakh, maybe 1 crore. Everything is countable. Only when we say infinite, that is not countable. Okay, so how do we find the location of the center of mass? So location of center of mass, right, will be given by the weighted average of the coordinates of individual particles. So how do we give the center of mass location? It will be given by what? The weighted average. What is the weighted average? We will see. Okay, say for example in our system, right, we have particle m1 with the coordinates x1, y1, z1. We have another particle m2, coordinates x2, y2, z2. We have another particle m3, coordinates x3, y3, z3, like that. Then the center of mass x coordinate, right, will be given by the weighted average m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Just break the formula and see what is it like. M1 by m1 plus m2 plus m3 into x1. Then m2 by m1 plus m2 plus m3 into x2. Then what do we have? m3 by m1 plus m2 plus m3 into x3. So how is it given? The weight of the particle by total weight. Means the weight fraction is taken as the weightage. So it is what? It is like the weighted average. So what is the weightage based on? The weightage is based on mass of the particles. The weightage is based upon what? Mass of the particles. Okay, so the center of mass x coordinate is what? m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, like that. Okay, now what will be the y coordinate of the center of mass? Same formula, right? What will be the y coordinate? It will be what? So if you have to write the y coordinate, means what is it going to be? Y coordinate of center of mass will be what? m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. If you want to write the z coordinate, right, what is it going to be? m1 z1 plus m2 z2 plus m3 z3 by m1 plus m2 plus m3, like that. Here we are taking 3 particles. If you have 4 means 4 terms will come, 5 means 5 terms will come. Okay, so this is how we will be able to locate the center of mass for discrete particles. So we are looking at countable number. It may be 3 particles, 2 particles, it may be 5 particles, anything countable. Okay, so that is the way in which we will be able to find the center of mass location. So here you can write some general formula also. So what will be general formula? If you have, like, totally n number of particles, sigma mi xi divided by sigma mi. So I will be changing from 1 to n, like the way we have seen, right? m1 x1 plus m2 x2, like that. Similarly ycm also we will have, similarly z center of mass also. Okay, so this is the general notation. Okay, but what is it actually? Whatever the number of particles we are having, right, for all of them we will have to multiply the mass with the respective coordinate, add all of it, that is the numerator. Denominator, what is it? Total mass of all the particles in the system. Okay, so this is how we are going to find the center of mass location for discrete particles. We will see some questions. Okay, look at this one. Consider the following system of 4 particles. What are the masses? m1, m2, m3, m4. located at the corners of a square side length A. So here this is the origin. Okay, so there are totally how many corners are there? 4 corners. Find the center of mass of the system with respect to the origin. Means we have to find the center of mass. Means what they are asking us, because here they are kept on what, all the particles are kept on xy plane, right? So we'll have what, x coordinate will be there and y coordinate will be there. Look at this, m1 is at the origin, means 0, 0. m2 is on the x-axis. What is this length? Side length, right? So m2 coordinates will be what, a, 0. Why a, 0? Because it is on the x-axis. What about m4? m4 is on the y-axis. This distance is what, a, right? So it will be what, its x coordinate will be 0. Now what about the m3? A. So m3 will be having coordinates a, a. So just write them down. m1 is what, 0, 0. m2 is what, a, 0. m3 is what, a, a. m4 is what, 0, a. Now what is the x center of mass formula? m1 x1, that is 0. m2 x2, m3 x3, m4 x4, that is also 0. Divided by m1 plus m2 plus m3 plus m4. So check it, what is it? m2 plus m3 into a divided by m1 plus m2 plus m3 plus m4. That is our x center of mass. Similarly, we can write the y center of mass also. What is it? m1 y1, that is 0. m2 y2, that is also 0. m3 into a plus m4 into a divided by m1 plus m2 plus m3 plus m4. Okay, so what is it basically? m3 plus m4 into a divided by m1 plus m2 plus m3 plus m4. That is what the y coordinate of the center of mass. It's a straightforward thing. So all we need to do is what? Just go as per the formula. It is what? The weighted average. The weightage of the location coordinates, right, is based upon the mass of the respective particles. The weightage is based upon what? The mass of the respective particles. So here what are we having? All the particles are in the xy plane. So the center of mass location will have the x coordinate as well as the y coordinate. Sometimes what happens, all the particles will be in a single straight line. Sometimes all the particles can be in a single straight line. Then we will be taking only one coordinate. Like say for example, all of them are in the x-axis. Then they will be having only what? The x coordinates. If all of them are in the y-axis, then they will be having only the y coordinate. If all of them are in the z-axis, then they will be having only the z coordinate, like that. Okay, let us see one more question. Consider 8 particles at the corners of the cube. The side length of the cube is what? A. Find the coordinates of the center of mass. What do we need to find? We have to find the coordinates of the center of mass. Check it here. So this is how, this is the origin, right? m4 is kept at the origin. m4 is kept at the origin, which means, so here it's a cube, it's a 3D object, means we will be able to find x coordinate, we can find the y coordinate, we can find the z coordinate also. It is just going to take a little bit time. Why? Because you will have to write down the coordinates of all the particles. See here, m1 is on the y-axis. Okay, m1 is on the y-axis. m8 is on the z-axis. m3 is on the x-axis. Okay, so we have to write down the coordinates of each and every particle. First we have to write down the coordinates of each and every particle, then we can use the weighted average formula. Take some time. Write down the coordinates of each and every particle. Let us see. So m4 will be what? Origin means it will be 0, 0, 0. Okay. Like that, one by one particle you take and try to write the coordinates. Because once you're able to get the coordinates, that's it. We are able to get the answer for this, right? Why? Because if you are having the coordinates means that is it. No, we will be able to straight away go for the weighted average formula. The thing is to get that coordinates. So let me show you the representation here, starting with M1. So where is our M1? M1 is on the y-axis, right? Means x coordinate is 0, z is 0. The side length of the cube is what? A. That is why the y coordinate will be what? A. So observe this, guys, carefully. What is the M1 coordinates? M1 will be having the coordinates of what? 0, a, 0. Now let us go to the M2. Where is M2? See, M2 is here, right? M2 is here means look at this. Along the x-axis we have to cover a distance a, and along the y-axis we have to cover a distance a, means x coordinate a, y coordinate a. It is in the xy plane. M2 is in the xy plane, so z coordinate will be 0. Clear? So like that we have to write down for each and every point. Then let us go to the M3. Where is M3? Look at where is our M3. M3 is here, sitting straight on the x-axis, means x coordinate is a, y is 0, z is 0. Okay. Then what is the next one? M4. Where is M4? That is our origin, right? So 0, 0, 0. What next? M5. Where is our M5? Okay, M5 is here. So look at this. M5 is actually on the ZY plane. Look at this. Y, we have to cover a distance A. Then along the Z axis A means M5. ZY plane means what? X coordinate is 0. Y coordinate A, Z coordinate A. Okay. What about the next? M6. Where is M6? Look at where is M6. Okay, M6 is here. Look at this now. M6 will have all the coordinates. How we'll check it? Cover distance A along the x-axis. Cover distance A along the y-axis. Then cover distance A along the z-axis. A, A. M7. Where is M7? M7 is on the XZ plane. Look at M7. Okay. So we have to cover a distance A along the x-axis and A along the z-axis. So M7 is what? A x coordinate, A z coordinate, y is 0 because it is on the xz plane. Last M8. M8 is on the z-axis. X coordinate 0, y coordinate 0. Only there will be what? The z coordinate. That's it, right? So what is the center of mass x coordinate? M1 x1. So we have to see where. So M1 x1 is what? 0. M2 into A will come. Then M3 into A will come. Then M6 into A will come. Then M7 into A will come. So totally if you take A common out means divide by M1 plus M2 plus M3 plus M4 plus M5 plus M6 plus M7 plus M8. That is our center of mass x coordinate. Okay. Similarly, we can write the y coordinate. Similarly, we can write the z coordinate, because the thing is what? Getting the table is the thing. Once you are able to get the table means this is like anyone's question. Okay, using the table we can write down. So can we write down the y coordinate here? M1 plus M2 plus M5 plus M6 into A divided by M1 plus M2 plus M3 plus M4 plus M5 plus M6 plus M7 plus M8. The last is what? The z coordinate. So what will be z coordinate? Can we write it here? Where we will get m5 plus m6 plus m7 plus m8 into a will come, because only from here we will have non-zero values. Divide by what is it? m1 plus m2 plus m3 plus m4 plus m5 plus m6 plus m7 plus m8. So this is just to get ourselves a little bit more practice, huh? Okay. So we have to see how we will get these center of mass. So if at all there are any questions, usually like this kind of questions we will not be able to expect. I mean, JEE advanced level we will not be able to expect. But if at all any questions are coming in the mains level, right, it will be a little bit tricky like this. They might give us a 3-dimensional shape like that, or even they may give a 2D shape. Okay, they may give a 2D shape where the particles will have all the coordinates. Like, the particles may have x coordinate, particle may have y coordinate, particles may have z coordinate. Then they will be asking us to find the center of mass. So we'll have to see some more models of question, then we'll understand. Okay. So like this we will be able to use the weighted average formula. Okay. Now we'll see in the previous questions, right, they were actually giving us what is the origin. They were telling us which direction is x-axis, which is y-axis, which is z-axis. They were giving us the coordinate system also. But look at this question. No, two particles mass 2 kg 8 kg are at a distance 8 meters. Means what? 2 kg is here, 8 kg is here. What is the distance between them? 8 meters. What is the distance of center of mass from the 2 kg particle? See this closely. What they're asking us? They're asking us the distance of the center of mass from the 2 kg particle. But all this time what we were studying? We were studying the method to find center of mass location by using the coordinates, right? Suddenly they are asking us distance. Can we tell what is the distance? Straight away we can't tell it, right? We have been studying what? The coordinates formula. Straight away how can we tell distance? We cannot tell. So what is it that we need to do? We need to change the problem into coordinates question. How? They are asking us to find the distance from 2 kg particle, right? So usually what we will do in these kind of questions is, from whichever particle they are asking us the distance of center of mass, right, make that as the origin. That is usual procedure. Make it as the origin. And we will have to take the directions of x-axis, y-axis. So here the thing is 2 kg 8 kg they are lying on one line, right? Let us take the line itself as the x-axis. That is it. Here there will be no need for discussion about the y-axis and z-axis because they both are lying on the same line. Look at this. Here only the x coordinate comes into picture because they are lying on the x-axis, right? What is the x coordinate of the 2 kg? 0. That is the origin. What is the x coordinate of that 8 kg particle? Because they are saying distance between them is 8 meters, right? So it will be what? 8 meters. Okay. Now using these coordinates, right? See what we are doing? We are trying to convert the problem which is in terms of distances into first coordinates. Now we will use the center of mass x coordinate formula. What is it? m1 x1 means 2 into 0 plus m2 x2, 8 into 8 divide by m1 plus m2 means what? 2 plus 8. So this is 0. 8 8 0 what? 64 by 10 means what? 6.4. Unit will be meter, right? Means the center of mass x coordinate is what? 6.4 meters. Center of mass x coordinate is what? 6.4 meters. What is the question they are asking? What is the distance of center of mass from 2 kg particle? See what is it? If the x coordinate is 6.4 meters means from origin what is the distance? 6.4 meters only, right? So you can see here from 2 kg distance of center of mass is what? 6.4 meters. What about the distance from the 8 kg particle? Overall distance between 2 kg and 8 kg is what? 8 meters, right? This side 6.4 means What will be on the other side? 1.6 meters. Okay, so we got the answer for this question. What is the answer for the question? Distance of the center of mass from 2 kg particle is what? That B or whatever you want to call it will be 6.4 meters. Check it, guys. But more than that, right, I want you to observe this importance here. The important point is center of mass of two particles. Here we are having, what are the two particles we are having? One is the 2 kg particle, other is the 8 kg particle. The important point is center of mass of these two particles, right, is closer to the heavier mass, isn't it? Observe this result carefully. The distance of center of mass from 2 kg is what? 6.4 meters. Distance of the center of mass from 8 kg is what? 1.6 meters. Means what? Center of mass, if you take the center of mass of two particles, right, center of mass will be always closer to the heavier one, isn't it? So this is an important result. Just make a note of it. We will see. Okay. Okay, guys. Let us go to the next question. This is another question where they are not giving us the coordinates. They are not giving us the coordinates. They are giving us the particles and geometrical representation. So we'll have to see what are they asking in the question. Three particles, 1, 2, 3 masses are placed at the corners A, B, C respectively of an equilateral triangle. Edge length is 1 meter. Means we have the three corners. We have the three corners. A is here, B is here, C is here. Okay. What are the masses we are keeping there? 1 kg, 2 kg and then 3 kg. Edge length of this is equilateral. Okay. Find the distance of their center of mass from the A. So from A we have to find the distance of the center of mass. Check how we can do it. As I said, right, whatever particle from where they are asking us the distance, make that as our origin. Make this as origin. Let us call this as the x-axis and let us call this as the y-axis. Okay. Now we'll write down the coordinates here. A will be what? That is the origin, right? 0, 0. Here it is like the triangle is in the xy plane, right? So no concept of z coordinate. Z coordinate will not come. Only x coordinate will come. Y coordinate will come. Now look at the B. B is on the x-axis. So its y coordinate is 0. What about the x coordinate? What is the side length? 1 meter, right? So it will be 1, 0. What is side length? It will be 1, right? It will be what? 1, 0. Now we have to find out what will be the coordinates of the point C. See, point C, if you draw an altitude, right, it will be equilateral triangle. Altitude will bisect the, because for an equilateral triangle, altitude, median, everything will be same. So this distance will be what? Half. So for the point C, x coordinate will be half. What about the y coordinate? The y coordinate will be the height. For an equilateral triangle, right, what is the height? Root 3/2 into A. This is a standard result, right? For an equilateral triangle, what is the height of the equilateral triangle? Root 3/2 into A. Which means what? A is the side length. Okay. So this will be what? Root 3/2 into 1 means, because side length is 1 meter, right? So it will be what? Root 3/2. So these are the coordinates. These are what? These are the coordinates of the point A, point B and then point C. Now what is our task? We have to find the center of mass coordinate. X center of mass means what? M1 is 1 kg. 1 into 0, that is 0. 2 into 1, that is 2. Then 3 into half, that is 3/2. Divided by, what is there? Total mass means what? 1 plus 2 plus 3 means that is 6. So check it, what is it? 7/12. What is the center of mass x coordinate? Is what? 7/12. What about the center of mass y coordinate? M1 y1, that is 0. M2 y2, that is also 0. Only M3 y3 will come. So 3 into root 3 by 2 divided by 6. That is what? 3 root 3 by 12. Okay, so x center of mass is what? 7 by 12. Y center of mass is what? 3 root 3 by 12. Now the coordinates of the center of mass, we'll write it as what? Center of mass coordinates are what? 7 by 12 comma 3 root 3 by 12. These are the center of mass coordinates, but they are not asking us the center of mass coordinates. In fact, they have not even given us which is the x-axis, which is the y-axis, like that, right? We are assuming all these things. What is the original question? Original question, they are saying, tell the distance of the center of mass from point A. That is the original question, right? So what will be the distance of this point? What is the distance of any point from origin? If you have the x coordinate and y coordinate, right? What is the distance of the point from origin? Root of x coordinate square plus y coordinate square, right? Which is what? Root of 7 by 12 the square plus 3 root 3. So what is it? 12 will anyway come out. Root of 7 square is what? 49. 3 root 3 square means what? That is 27. Correct, because 3 root 3 is what? Root 27, right? So 49 plus 27 is what? That is 76. So what is it? Root 76 divided by 12. Check it. What is the distance of the point from the vertex A? Root of 76 by 12. If you want, we can see there can be further simplification. So can we do further simplification? Yes, right. So root 76. 76 means what? What is 76? It will be 19 fours are 76, right? So 2 root 19 divided by 12, that is what? 1 by 6 into root 19. Okay, so this is about the distance of the center of mass from the vertex A. So all these questions, right, whichever we have question like this, same pattern, we have to assume the, see, it's a very blind rule most of the cases, right? They will say find the distance from the point, take that as the origin, then you decide the x-axis, y-axis, like that. Accordingly we have to proceed. Check it, guys. So here the only thing is, if we know that the properties of the equilateral triangle, right, it will help us to get the answer fast. Otherwise, you know, we'll have to calculate the height of the equilateral triangle. See, by now itself, because we'll keep using these common geometrical shapes, right, whether it is the rectangle, square, trapezium or parallelogram. In case of triangles means we will be commonly using the equilateral and then isosceles and right angle. Some of the properties of these triangles, right, we must be very comfortable with. Okay, so I guess you are able to get the answer for this. What is the answer? Either we'll say root 76 by 12 or root 19 by 6. Now that I showed you the previous question, right, let us see if you guys can do this. Just little bit more, one step extension, but it will be easier than the previous one. 4 particles, 1, 2, 3, 4. See, whenever they give it like this, right, we have to take in the same order. Most of the questions they will say respectively like that, but otherwise also we have to take in the same order. 4 particles, 1, 2, 3, 4 are placed at A, B, C, D of the square. So look at this, A, B, C, D. A is here, B is here, C is here, D is here. Okay. Find the square of the distance of their center of mass from A. So this is something, you know, see, this is how something, sometimes they will just tweak the question. They are not asking us the distance, they are saying what? Find the square of the distance. So in the hurry, if we are not reading this line, right, so having done the entire question, because in the options we will have the actual distance will be there, D. Because if D is the distance of the center of mass from A, then the 4 options, right, they will give us D, they will give us D square also. In this question what they are asking D square, they are not asking us the D. Okay, so look at this. Here we have 1 kg, here 2 kg part, here there is a 3 kg, here there is a 4 kg. Same way, right? We will have to tell. So let us assume the what is the general assumption or general thing that we proceed. We will take this as our origin, x-axis, y-axis. Now I will tell you the coordinates position. You can tell me whether it is correct or not. A will be 0, 0. A will be what? 0. That is our origin. B is on the x-axis. Side length is what? 1 meter, right? So B will be 1, 0. D, C also will put. D is on the y-axis. So it will be 0, 1. C will be what? Look at it. We have to cover 1 meter. 1 meter. C will be what? 1, 1. These are the coordinates. I said this will be simple. Why? Because here we will not have that root and all that. So this is our coordinates. Now x center of mass means what? What is x center of mass? Means m1 x1 0, m2 x2 that is 2, m3 x3 that is 3, divide by here m1 plus m2 plus m3 means what? What is this? 1 plus 2 plus 3, 6 plus 4, 10. Numerator is 5. 5 by 10 means what? That is half. That is the center of mass x coordinate, half. What about the center of mass y coordinate? Same concept, right? m1 y1 0, m2 y2 that is also 0, m3 y3 means 3, then m4 y4 4. This is what? 7 by 10. That is either we can also keep it as like 5 by 10, like that we can keep it. That is 5 by 10. This is 7 by 10. They're asking us what? Square of the distance means x center of mass square plus, because distance from origin means what? D is what? D is what? Root of x square plus y square for any particle. Square of the distance they're asking means it will be x center of mass square plus y center of mass square. What is it? 5 by 10 the square plus 7 by 10 the square. That is it. We'll just have to simplify. 5 square means what? 25. 7 square means what? 49. Okay, so what is 25 plus 49? Because denominator is same for both of them, 100. Denominator is same, right? 100. 25 plus 49 is what? What is 25 plus 49? It is 74, right? We can leave it as it is, or we can simplify. We can cancel. Okay, check it guys. What is the answer? 74 by 100, or we can cancel, means it will be what? 37. 2s are 74, right? It will be 37 by 50, like that we can cancel and write. Otherwise we can leave it as it is. So the thing is what? Here they are asking us what is the square of the distance. That is the trick. Okay, so if you are getting that point wrong, means the entire answer will be going for a toss. Is it clear? So this is how we will be able to find the center of mass for a discrete system of particles. Okay, now here we will see some of the results. Already we have got some of the things, right? We will see center of mass of two particle system, like the way we discussed the 2 kg and 8 kg example, right? Center of mass of two particle system lies on the same straight line joining the two particles. Remember, where was that? From the origin, this is what we took as origin, right? It was at a distance of 6.4 meters. From the 8 kg, it was what? 1.6 meters, right? So it is lying on the same straight line between the two. It will not be midpoint, it will be between the two. Okay, is it clear? So the center of mass of the two particles, right, will be located near to the heavier particle. So first thing is what? It will be located between the two, and that also we have seen, right? Distance of the center of mass from 8 kg is what? 1.6. means, remember, this is what we said, the center of mass will be more closer to the heavier particle. It will be more closer to the heavier particle. Okay, when it will be exactly in the midpoint, if both the mass are equal, right? If both the mass are equal, then center of mass will be at the midpoint. Both the mass are equal, then center of mass will be at the midpoint. Why? Because look at this, axiom formula will be what? m1x1 plus m2x2 by m1 plus m2, right? m1 is equal to m2 means what is it? m into x1 plus x2 by 2m. So what is the center of mass coordinate coming as? x1 plus x2 by 2. What is this? This is the midpoint formula, right? If you have two locations with coordinates x1 and x2, what is the midpoint formula? x1 plus x2 by 2, right? So if you have both the mass equal, then the center of mass will be at the midpoint. Okay. Now we have seen the center of mass location in terms of the separate. What is the x coordinate? What is the y coordinate? What is the z coordinate? Like that. We can club them and write it in the vector form. What is vector form means? See, origin is here. If you are drawing a line from origin to the location, any location you take, that is what we call as the position vector. So for any particle, right, what is the position vector represented by? Its x coordinate into I cap, y coordinate to j cap, z coordinate to k cap. What is it? X coordinate into I cap, y coordinate to j cap, z coordinate into k cap. Now similarly, if we are talking about the center of mass location, what is center of mass location? We are saying it is having x coordinate, y coordinate, z coordinate. Center of mass position vector from origin will be what? X center of mass into I cap, y center of mass into j cap, z center of mass into k cap. Look at this. What is the center of mass position vector? It will be what? X center of mass into I, then y center of mass into j, then z center of mass into k. So we'll just do a little bit of rearrangement. So here x center of mass means what? Let us say we are having two particles. Okay, x center of mass means what? m1x1 plus m2x2 divided by m1 plus m2 into I. Then what is this? m1y1 plus m2y2 by m1 plus m2 into j. Then what else we have? m1z1 plus m2z2 by m1 plus m2 into k. So what we'll do is first we'll take out this m1 plus m2 common. That is the denominator, of course. See here, m1x1i plus here m1y1j plus here m1z1k. Then what else is there? m2x2i, m2y2j here, then m2z2k. So we are keeping all the m on once, all the m1 together, all the m2 together, like that. Okay. Now observe this carefully. We are going to write the final step. So we are going to get the formula for locating the center of mass in terms of the vector form. Here vectors means what? We are talking about the position vectors. So look at this here. If you take m1 common out, okay, so what is this? Center of mass position vector is equal to what? 1 by m1 plus m2. Take m1 common. What is it? x1i plus y1j plus z1k. Similarly here m2 common. Okay, x2i, y2j, x2i, y2j, z2k. So what is this one? 1 by m1 plus m2, m1 into what is x1 into I, y1 into j, z1 into k. What is it? The particle 1 position vector r1 bar. What is x2i plus y2j plus z2k? That is the particle 2 position vector. So look at this. Finally we are getting the formula. If we want to find the center of mass location in terms of the vector notation, if you want to find the center of mass location in terms of what? Vector notation, right? What is it that we are having? The position vector of the center of mass will be given by what? m1r1 plus m2r2 divided by m1 plus m2. This is just like what we have seen. Previously we were seeing in terms of the separate coordinates, right? Now it is in terms of the position vectors. If you have three particles, means what is it? Center of mass will be what? m1r1 plus m2r2 plus m3r3, like that, divided by m1 plus m2 plus m3. 4 means 4 terms will come, 5 means 5 terms will come. Okay, so this is how we will be able to find the center of mass position vector form. Okay, that is related to what? The position vectors of the respective particles. That is related to what? Position vectors of the respective particles. Okay, so this is another important result in terms of the center of mass identification. So all this is what we are trying to identify. What is the location of the center of mass. Now in this previous formula, right, we were seeing this m1r1 like that, right? m1r1 bar, m2r2 bar. Each of these things, there is a name that we give for it. Okay, what is this called as? Moment of the mass of particle 1 about the origin of the coordinate system. This is the moment of mass. So m1r1 bar is called as what? Moment of mass of particle 1 about the origin. m2r2 bar will be called as what? Moment of mass of particle 2 about the origin. Okay, so this is, if you have third particle, m3r3 bar will be called as what? Moment of third particle about the origin. Okay, so this is an important term that we'll keep using. What is it called as? Moment of mass of the particle about the origin. Okay, now this is a very important point about the center of mass location. The geometric location of center of mass, right? So if you are indicating the center of mass by a point P, the geometric location of center of mass does not depend upon the choice of the coordinate system. Okay, so for example, let's say we are having two particles in that system, m1, m2. This is our origin O. We are getting the center of mass location like this here. I'm just giving some example. This is the point P or the center of mass, whatever you call it. If you change the origin from here, if you make the origin to be different point, let's say we are changing the origin from here to O dash. What we will be thinking is, because look at the formulas we had. What is the formula for the center of mass position vector? We were using m1r1 plus m2r2 by m1 plus m2, right? That is the formula. So if you change the origin, means r1 bar will change, r2 bar also will change, right? If you change the origin, means r1 bar is what? The position vector of the particle 1 with respect to origin, right? r2 bar is what? Position vector of particle 2 with respect to, both of them will change. So this will change the center of mass position vector, because the center of mass position vector, right, will be based upon the new origin. Center of mass position vector value will change, but the geometrical location, right, the geometrical location will remain the same. See, the coordinates are something that will depend upon the origin of choice and the coordinate system, right? But the geometrical location will not change. So even if you select some other point as origin, right, we will get the geometric location will be P only. But in the new coordinate system, see, in the old coordinate system, I'm just giving you one simple example. P is having the location coordinates 1, 2, 4 like that, as per the old system. As per the old coordinate system, P is having the coordinates 1, 2, 4. The new system might have the P coordinates as maybe 1.5, 2.8, 4.8, some numbers as per the new system. Coordinate values might change, but geometric location will be as it is. So this is an important point. What is it? The center of mass geometrical location will not depend upon what is the choice of the coordinate system. It will not depend upon what is the choice of the coordinate system. Okay, the values of the coordinates might change. The values of the coordinates might be changing. So here we will see something very interesting now. Okay, so we said we have two particles. For that we are talking about the center of mass. Okay, now let us see one very interesting case. So this is our m1, that is our m2, right? This is the original origin. What if we change the origin to the point P itself? Okay, so what if we change the origin to the point P itself? Means the new origin is what? This is our new origin. The new origin is what? Center of mass itself. The new origin is what? Center of mass. If center of mass itself is our origin, right? Then look at this. This is R1, this is R2. As per the new system, what is the formula for the R center of mass? Either we put smaller or capital, whichever it is. What is the formula for the center of mass position vector? M1 R1 plus M2 R2 by M1 plus M2, right? But if in the new system the origin itself is center of mass, right? Then what will be the position vector of center of mass? 0, isn't it? So means what? We will have M1 R1 bar plus M2 R2 bar will be 0. Why is it happening? It is happening because we are shifting our origin to the center of mass itself. Okay, so this is also in some textbooks, right? You will see it like a standard statement. They will say the sum of, so I'll just write down the statement, then you will be able to understand what is the meaning of the statement. Okay, so this is what you will see in some textbooks. Okay, the sum of moments of masses for a system of particles, the sum of moments of masses for a system of particles with respect to center of mass is 0. Remember, what is moment of mass means? What we said? M1 R1 bar, that is the moment of mass. If you take the origin itself as center of mass, then what is the value of all those M1 R1 bar? Like in this case we have two particles, right? If you add up the M1 R1 bar plus M2 R2 bar means 0. Why? Because we are taking the origin itself as the center of mass. Okay, so this is another important result about the center of mass location in terms of the position vectors. But before we wind up the session, right, let us just quickly solve this question. So position vector of the three particles M1, M2, M3, they are what? 1, 2, 3, R1, R2, R3 is given. Find the position vector of the center of mass. So first of all, you know what is M1 plus M2 plus M3 here? Same way, right? What is M1 plus M2 plus M3 means? 1 plus 2 plus 3 is what? 6 kg. What is M1 plus M2 plus M3? That is what? 6 kg, right? Now, what is R bar Cm? What is R bar Cm? M1 R1 bar means 1 we have to multiply. The value will not change. I plus 4j plus k. M2 R2 bar means 2 we have to multiply this R2. It will become what? 2i plus 2j plus 2k. Then M3 R3 bar means M3 is 3 kg. We have to multiply 6i minus 3j minus 6k whole divided by M1 plus M2 plus M3, that is 6. I is there, 2i is there, 6i is there. What is it? Totally 9i. 4j is there, 2j is there. 4j plus 2j is what? 6j. Minus 3j means 3j will be there. Okay. Then what else is there? K, 2k. What is it? Minus 3k. So what do we have? 3 by 2i plus 1 by 2j minus 1 by 2k. What is the answer? 3 by 2i plus 1 by 2j minus half k. Okay, so check it guys, whether you are able to get the same answer or not. Okay, so this is about finding the location of the center of mass in terms of the position vector. Okay, so with this we'll wind up the session. In next class, right, we will start discussing about how do we find the center of mass location for a extended body, and then we'll talk about the significance of center of mass. Okay, we will see in the next class.